Hi, today we are talking about section 7.5, surface areas of prisms. The surface area of a solid is the sum of the areas of all of its faces. Faces are the sides of the solid. So for surface area, we are finding the sum, we're adding the areas of the surfaces of the shape or the sides of the shape. You can use a two-dimensional representation of a solid called a net to find the surface area of the solid. We'll talk about the net a little bit more in a bit. Surface area, it's an area, is measured in square units. So I want you to think it's just like how you were labeling your area problems for 2D geometry shapes. Okay, so here you see the net of a rectangular prism. A net is basically when you take a 3D shape and you unfold it. I always like to pick one of the faces and unfold around that. So in this picture, they took the back of the shape and they unfolded this left side to the left, the right side and the front were attached to unfold on the right. The top unfolds upwards and the bottom unfolds down. So you'll see this mid unfold and when it's flattened. You are welcome to use a net, draw a net for surface area and do the areas of each of the parts. I have another method that I'm going to show you that works best for those of us who are not necessarily visual people. So in example 1, we are working with the surface area of a rectangular prism. Now rectangular prisms are special because opposite sides of a rectangular prism are identical. So that's going to help us shorten the amount of work we need to show. So what I like to do is list out the sides that I see. I see the front, the back, the left, the right, the top, and the bottom. And I'm going to pair up the ones that are identical. So I have the front and back, the left and right, the top and bottom. And I'm going to show my 3 steps like we talked about with our 2D geometry shapes for each of those. So for the front and back, I see rectangles, so I'm going to do area equals length times width. You plug in the dimensions, so I'm looking at this front rectangle and I see its dimensions are 7 and 3. And I multiplied to get 21. Now, if you have trouble identifying what the dimensions are, you can actually trace with your finger or your pencil the outline and see what dimensions you cross over when you outline that piece, that face of the solid. Now, because I'm referring to the front and the back, I have to double this number. And my area is going to be 42 for the 2 of them. Now I'm going to do it for the left and right. The left and right, as you can see, are also rectangles. I'm going to outline. I'm pass through 4, and then I don't pass through another number, but I do know that this other dimension matches this dimension because opposite sides of rectangles are equal. So I'm going to do 4 times 3. I get 12, and I'm going to double that to get 24. Okay, and then we have the top and the bottom. Length times width. Top and bottom, I'm going to outline the bottom. I see I pass over 4 and 7. Gives me 28, and I'm going to double it for both the top and the bottom. For our final step, we're just going to add the 3 together. And that gives me 122 inches squared. Okay, so next we have the net of a triangular prism. Again, just unfolding it. You pick a side that you want to unfold around. This picture is showing it unfolded around the bottom or the base. Actually, not the base, just the bottom of the shape. So we have this side unfolds, the left side unfolds, the back, and the front, and it creates this. You can use this for surface area and break it apart. I'm going to show you the other method as well. Okay, so triangular prisms are not as convenient as rectangular prisms because the opposite sides are not always equal other than the bases, the identical opposite bases. So here I see the front and the back, which are identical because they're bases. I see, I'm going to call this the top, the bottom, and then the right. And you can call those whatever you want. You don't have to use top, bottom, and right if that doesn't work for you. The front and the back are both triangles, so I'm going to use my triangle formula. For my triangle, I see I cross over 12, and then going up here, if I look across, 5 is the height, so I'm going to use 5 there as well, which gives me 30. The top is a parallelogram, or you could use the rectangle formula because they're very similarly related. I'm going to outline 13, and this other dimension is going to match here, which is 8. And that gives me 104. Now for the bottom, which is also a parallelogram, we see 12 and 8 are the dimensions, which gives me 96. And then the right piece, another parallelogram. We have 8 and 5 are the dimensions, which gives me 40. Now I want to make a note, the bottom and the top are not equal to each other. You can see they have different measurements. One has 13 for a dimension and one has 12. So now that we have all of these, we're going to add them together. Oh, we got to double this one actually, because there's 2 of them. And that gives me 300 centimeters squared. Okay, next, when you have a cube is a rectangular prism or a square prism where all of the dimensions are the same. So we do have a formula for that one, which shortens the amount of work that you need to show. We're going to do the surface area is side squared, which gives me the area of one of the sides. And then you're just going to multiply that by 6 because there are 6 faces on a cube. So for example 3, we've got a cube. We know it's a cube because all of the dimensions are the same, so we're going to use our formula. S equals 6s squared. S equals, so we're going to do 6 parentheses 12 squared. And then we have to follow PEMDAS. 12 squared is 144. And then we're going to multiply by 6 because there's 6 faces. That gives me 864 meters squared. Okay, last example, modeling real life. I'm sorry you can't see the picture here. The printer wasn't doing great today. So the space instruments are often wrapped in gold-colored multi-layer insulin, MLI, to reflect radiation from the sun. What is the least amount of MLI needed to wrap an instrument in the shape of a rectangular prism? So this is a rectangular prism with a length of 5 feet, a width of 5 feet, and a height of 5 feet. It might help you, this is why we learned how to draw these. It might help you to just draw a rough sketch and label the length of 5, the width of 5, and the height of 3. So we're doing surface area for this because we are wrapping around the shape and we want to cover the surfaces of the solid. So I'm going to do front and back, top and bottom, and left and right. They're all going to be rectangles. This is a rectangular prism. For my front and my back, I have 5 by, going up is 3, which gives me 15, and I double it. For my top and bottom, here's my bottom piece. My dimensions are 5 and 5. Gives me 25, and I double it. And the left and the right, here's the right side. My dimensions are 3 and 5, which gives me 15, and I double it, which gives me 30. My final step for the surface area, I noticed I haven't been writing SA, I've just been writing A, surface area. I should have been writing S in front of the A there. I'm going to add them together, and that gives me 110, and I go back to my label, feet squared, and that is the end of the 7.5 notes.